Hi, Assalamualaikum. We are from class CDCS 1431A. We will presenting our group under the course MAT123 Foundation of Geometry, which is geometry is an application in real life. Firstly, I'm going to talk about our first case, is Stadium Bukit Jalil. Specifically, the reason why we choose the Stadium Bukit Jalil is because of the architecture of the stadium football. Before we continue to calculate the area of the stadium, I need to share the Stadium Bukit Jalil history. Firstly, the Stadium Bukit Jalil is in Bukit Jalil, Kuala Lumpur, Malaysia. With capacity of 87,411, it is the largest in Southeast Asia, the second largest in Asia, and the 8th largest stadium in the world. The stadium was built on 1 January 1995 to host the 1998 Commonwealth Games. It finished exactly on 1 January 1998. After the 1998 Commonwealth Games in September, the stadium became the home stadium for the Malaysian national football team, replacing the Shah Alam Stadium and the Medica Stadium. It also served as the main stadium of 2001 Southeast Asian Games, 2006 Pacific Games, 2008 ASEAN University Games, and 2017 Southeast Asian Games. It was built by United Engineering Malaysia Berhad and designed by architect FAR. It was completely 3 months ahead of schedule. The stadium and the National Sport Complex are undergoing a major renovation at a combined cost of 1.34 billion ringgit.
And now, I want to explain why Stadium Bukit Jalil must make an improvement. These factors considered as potential for improving Stadium Bukit Jalil. Due to the building that had been built in the 90s and had not been assessed structurally for many years, stadiums need to ensure the safety and security of the spectators, athletes, and staff. Regular upgrades may be necessary to comply with the latest safety standards, implement advanced security measures, and address any potential vulnerabilities. The cost of the old building, they need to make sure the infrastructure and facilities may require upgrades to enhance the overall experience for attendees. This can include improvements to seating, restrooms, concessions, parking facilities, accessibility for people with disabilities, and other amenities. Other than that, the cause of poor field drainage system can be various of factors, which is insufficient or outdated drainage infrastructure. If the stadium's drainage system is not designed to handle the volume of water effectively, it can result in poor field drainage. This may be due to outdated technology or inadequate maintenance. Proper grading and slope also are essential for effective drainage. If the field surface is not appropriately sloped, water may accumulate in certain areas, leading to poor drainage. Also, weather conditions is one of the factors to lead to the poor drainage system. Heavy rainfall or prolonged periods of precipitation can overwhelm even well-designed drainage systems, leading to temporary drainage issues. Next, shape and construction of Stadium Bukit Jalil. The shape for Bukit Jalil National Stadium has a rectangular shape, which is the most common shape for large sports stadiums worldwide. The stadium has a seating capacity of approximately 87,411 spectators, making it one of the largest stadiums in Southeast Asia. The stadium consists of two main tiers. The lower tier surrounds the entire field and the upper tier is partially covered and run along the sides and ends of the stadium. For the accessibility, the stadium is designed to be accessible for people with disabilities. It includes ramps, elevator, and designated seating areas to ensure equal access for all spectators. Now, I want to show how to calculate the area of field of the Stadium Bukit Jalil. First of all, the shape of the field is rectangle. Formula area of the field stadium is length multiplied by width. The width of the field stadium is 68 meter and the field length is 105 meter. So the total that we got is 7,140 meters.
Next, I am going to calculate how many units of grounds to change the entire field stadium. First, we have the area of the field stadium divided with the area of grass. The area of the field stadium is 7,140 meters and the area of grass is 2 meter multiplied by 50 meter. So, 7,140 divided by 50, the answer is 143 unit grass. Finally, I want to finalize our calculation with the total of the money that we spent to buy the grass. The formula is the total unit of grass multiplied by the money of 1 unit of grass. The total unit of grass is 143 unit and the money for 1 unit grass is 595.63 cents. The answer is 8,517.9 cents. This is the total money we spent for the entire stadium. That's the end for the first case.
Now we will continue to our second case, which is basketball.
To steal one and come from 31 down. Keeping going left. Gilgis Alexander. Kick out to Shamet for three. He got it! Landry Shamet hits a three. And from 31 down to up two.
Next, we'll talk about the history of basketball. On the morning of 21st December 1891, Dr. James Naismith emerged from his office with an idea after spending 2 weeks searching for an indoor athletic activity to occupy his physical education class during the cool winter months. Naismith tried indoor adaptation of soccer, lacrosse, and football, but it only led to people getting injured. He was disappointed when he couldn't find an indoor sport, so Naismith decided to invent it. The first official basketball game was played on 20 January 1892. The first contest featured 2 teams. Basketball was originally played with a soccer ball and pitch basket, so someone had to climb on a ladder each time to get the ball out. Later, to make it easier, a hole was drilled into the bottom of the basket. Next, we'll look at the rule of basketball. Basically, basketball have 16 rules, but I just only read several rules to you. So 1. Only 5 players per team on the court. 2. Score more than your opponent to win. 3. Score within the shot clock. 4. Dribbling advance the ball. 5. The offense have 5 seconds to inbound the ball. 6. The offense must advance the ball. Application of geometry in basketball court. Let's calculate the area of basketball court in meter. When look at the picture of the basketball court, we will know that the length of the basketball court is 94 feet. Meanwhile, the width of the basketball is 50 feet. Now, using the area formula, length of the basketball will multiply by the width of the basketball court. So, 94 feet multiplied by 50 feet. The answer we will get is 4700 feet. After that, we need to convert it to the meter. So 1 feet is equal to 0.305 meter. The answer that we get before that is 4700 feet. Need to multiply by 0.305 meter. Then we get 1433.5 meter square as our answer.
Next, for the area and the volume of a basketball, we know that sphere is a complete curved shape. Therefore, the curved surface area is equal to the total area of sphere. It also called lateral surface area. So next, we want to present about an area of the basketball, which is sphere. The formula of the sphere is a 4 pi radius square. In this problem statement, an official NBA basketball has a radius of around 11.94 cm. So first, we need to calculate the surface area. Surface area of sphere is equal to 4 pi radius square, which is 4 multiplied with pi multiply 11.94 squared. So we got the answer is 1791.507 centimeters squared. Next, for the volume of sphere is equal to 4 over 3 pi radius cubic. The calculation is 4 over 3 multiplied with pi multiplied with 11.94 cubic. And total up, the answer is 7130.198 centimeter cubic. We move to another problem solving. Based on the pictures given, there are two different types of angle that we need to find, which is the angle of elevation and the angle of depression. These calculations are to determine the angle for the basketball player to focus off the target on the basketball hoop. Before we continue the calculation, I want to define the angle of elevation. The angle of elevation is an angle that is formed between the horizontal line and the line of sight. Based on the picture, the height of basketball player is 2 meters. Meanwhile, the height for the basketball hoop from a surface floor is 3.05 meters. And the length from a ball held to the basketball hoop is 4.20 meters. First of all, we need to find the height for a basketball hoop from the ball being held. To find it, we need to minus the height of basketball hoop with the height of basketball player, which is 3.05 minus 2, and the answer is 1.05 meter. After we got the A, which is 1.05 meter, we can find the angle of elevation. To find the answer, we use the formula of tangent A equal to A over B, which is 1.05 meter over 4.20, and the answer is 0.25. After that, we must bring the tangent to the right so we can find the angle of A. But when the tangent moves the place from the other place, it will be tangent inverse. So angle A equal to tangent inverse in the bracket of 0.25. So the final answer and the angle of elevation is 14.036 degree. Next, the angle of depression is the angle between the horizontal line and the observation of the object from a horizontal line. Based on the picture, we can see that the free throw line is in the same point to the angle of depression. So first, we need to create a triangle between the top of basketball hoop and free throw line. So in this case, we're still using the tangent to find the angle of depression. We use theta to refer to the angle. So the calculation is tan theta is equal to 3.05 over 4.20, and we got 0.726. To find the final answer, we must bring the tan to the right, and it will be tan inverse. So tan inverse in the bracket of 0.726, and the angle of depression we got is 35.98 degree. So that's all for the calculation of problem solving.
In conclusion, geometry is used in various aspects in our daily life. Geometry is very important for our life in process of planning, design, and construction the physical structure such as building, court, ball on the field. Geometry has many skills and contribute on growth the logical reasoning and solve problems that we had.